Hi everyone. So for our lesson for today, we're going to learn how to write down the balanced chemical equations for the reactions that we have learned the last lesson. So just to recap, we have learned how to come up with the identity of the salts for the three acid reactions, okay, and also for the two alkali reactions. So for salts, do remember that it is an ionic compound, okay, and we will always have a positive ion and a negative ion in each of the salts. Where do we get the identity of each of the ions from? For the positive ion, it is always obtained from the metal. Okay, sorry, let me change to a different color. The metal, the carbonates, and the base. Right, for the salts, we always get the positive ions from these three um, substances. And for the negative ion, it is always obtained from the acid. Okay, it's always obtained from the acid. For the alkali plus ammonium salt reaction, we always get salt, water, and ammonia gas. So same thing, the positive ion is, in this case, is always taken from the alkali, right? So it's the same as the previous reaction with the acid plus base. And the negative ion, on the other hand, is obtained from the ammonium salt. Okay, so let's try some questions together, and then as to see if you have learned, I will need you all to complete a page in your theory book and then upload later onto the Google Classroom. So let's begin. So if you could turn with me with your for your theory book to page 93. Turn to page 93. Okay, I'm going to go through with you some things first before we start with the questions, because these were common mistakes that I saw from your writing balance equations uh, exercise previously. So please do write down all this into your book, and it is a good recap as well. Okay, so what are the formats for writing the numbers in the chemical formula, and as well as for balancing chemical equation? Number one, if you have a subscript, okay, if you're writing a formula like H2O, the number 2 is written at the bottom right hand corner. So we call this a subscript. And it must be written at the bottom right hand corner, so at the right hand side. So what does a subscript mean? It means that it has that certain number of atoms or ions. So in this case, it means that there are two hydrogen and just one oxygen. Okay, there's no need to write a one. So if there's no number there, we understand it as one of it. Okay, number two, if you have a superscript means is the number at the top, is written at the top. Okay, a superscript is usually written at the top right hand corner, so at the right hand side. And what does it mean? It means it's the charge of ions. So whenever you write a number at the top right hand corner, it must be accompanied by a plus or a minus sign. And you will only write it at the top right hand corner if you're writing an ion, because it must have charges. Okay, number three, and this is the common mistake that a lot of you make. If you're writing a number that is of the same size as the alphabets, as the chemical formula, this can only be written at the left hand side of the chemical formula. So at the left hand side, and this is written as the same size. When you write something like this, it means that it's the coefficient that is used for balancing equations. So writing a 2 next to H2 in this case means that I have got two molecules of hydrogen gas, right? Two sets of H2 molecules. This is what it means, this 2 over here. All right. You cannot, what's the common mistake? The common mistake that a lot of you made is you write, like for example, the correct one is H2SO4, right? These two are subscripts. However, a lot of you wrote it this way, H2SO4. Right, you wrote it as the same size, and that is wrong. Okay, so please be very careful when you're writing the numbers. If you write it as the wrong size, you will have to be marked wrong, even though the combination is correct. Okay, so please be very careful with that. Okay, so let's start. So this is page 93. Page 93, we are going to work on review questions part B. Okay, and for all of these reactions, this table at the side is for you to help you to quickly identify what are the negative ions of each of the acids, and also just to give you what's the formula of ammonium ion as well. All right, so what are you supposed to do? You're supposed to write down the names of the products from the reaction, and you are also to construct the balanced chemical equation, including state symbols. Okay, there are some state symbols that you may not know yet. So in this question, they say that assume that all salts formed are in the equal state. Okay, so that is your bracket AQ. Okay, so let's start. Firstly, in all of this reaction, you need to be able to quickly connect it to which general reaction is it. Is it the um, is it the acid plus metal giving you salt plus hydrogen gas, or is it acid plus carbonate giving you salt, water, and carbon dioxide? So make sure you get the byproducts correct, not just the identity of the salt correct. Okay, so the first one, we have acid reacting with metal. Okay, so we should be getting salt plus hydrogen gas. So what are the products? To the salt in this case, the positive ion is taken from the metal, and a negative ion is obtained from the acid. Okay, so what do we have here as a salt? The salt will be magnesium, and for nitric acid, it is over here. So the negative ion is nitrate. And the byproduct here is hydrogen gas. Just writing it as hydrogen is sufficient. So what is the equation? Okay, so we have magnesium metal. Metal is a solid state plus nitric acid, that is HNO3, minus all acids are aqueous. Okay, so because of this, for the acid we have H plus and we have NO3 minus. That's why I got HNO3. So just remove that line over there on top. And what are my products? So remember, this is arrow, not an equal sign. For magnesium nitrate, magnesium is in group 2, Mg2 plus. Nitrate ion is NO3 minus. So we should be having Mg bracket NO3 close bracket 2. This is a salt, and just now we said all salts are in equal state, so this is bracket AQ plus hydrogen gas. Hydrogen gas is the formula H2 bracket G. Okay, so this is H2, not H. So let's balance our equation. Looking across, the common molecular ion over here is nitrate ion. All right, and I have two nitrate ion in magnesium nitrate, and there's only one nitrate ion in nitric acid. So I can balance it up by writing a coefficient 2 in front of HNO3. Then let's check. Our, our elements here, I've got MgHNO3 minus. Okay. On the left hand side now I have 1 magnesium, 2 hydrogen, and 2 nitrate because of the coefficient 2 in front. On the right hand side, I have 1 magnesium from here, 2 nitrate because of the bracket 2, and then 2 nitrate here, and then 2 hydrogen over here. Okay, so this is a balanced chemical equation. For the next equation, it is zinc carbonate plus hydrochloric acid. So if you look at the general reactions, this is an acid plus carbonate reaction, and you get salt water plus carbon dioxide. Okay, so let's figure out the products. So this is hydrochloric acid, and hence the negative ion over here is chloride ion. Okay, so this is chloride ion. And for zinc carbonate over here, we will obtain the positive ion, and that is the zinc ion. Okay, so our salt that is formed, it will be zinc chloride. And the other two products will be carbon dioxide plus water. So to write down our chemical equation, zinc carbonate has a formula of Zn2 plus, and carbonate is over here CO3 2 minus. So the formula should be ZnCO3. This is solid, so that's bracket S, plus hydrochloric acid is H plus and Cl minus, so it is HCl. All acids have an aqueous as state symbol, and we get zinc chloride. Zinc is Zn2 plus and chloride is Cl minus, so we should be getting ZnCl2. Carbon dioxide is CO2 gas and water H2O liquid. So zinc chloride state symbol is aqueous. Okay, so let's take a look. We can write down our elements for each. We can write down our elements and count the number of them that are present on each side of the equation. So we have Zn, C, O, H, Cl. Right, so on the left, I have one Zn from here, then one C, 3O, one H, and one Cl. So on the right hand side of the equation, Zn I have 1, Cl is 2, then carbon dioxide, so that means I get 1 carbon, 2 oxygen, and then H2O, so that is 2 hydrogen and 1 more oxygen. Okay, so when you look across the equation, the things that are not balanced will be oxygen, hydrogen, and Cl. Usually we'll leave oxygen and hydrogen to be the last that we balance, because there are a lot of them that are present in many of the chemicals. So let's start with Cl first. There's one chlorine on the left and two chlorine on the right. So to balance this up, we need to have two chlorine on the left hand side. To do this, we write a coefficient 2 next to HCl. Okay, so let's update our numbers. Now I have got 2 Cl and 2 hydrogen. All right, and actually, as you look across the numbers now, you'll notice that they are all equal to each other on both sides of the equation. And hence, this is our balance equation. ZnCO3, state symbol S, plus 2HCl equals arrow ZnCl2 equals plus CO2 gas plus H2O liquid. Okay, so that is for this equation. I will probably just do one more with you, and the rest of it you can try on your own. Okay, and I will give you the answer so that you can check your answer. Okay, so let's try number 4. For number 4, we have aqueous ammonium sulfate. So let's write down, let's figure out firstly which general reaction this will be linked to. This is ammonium sulfate, and I've got aqueous potassium hydroxide. So this is our ammonium salt, and then aqueous potassium hydroxide is an alkali. So this is actually our alkali plus ammonium salt reaction, and hence we get salt plus water plus ammonia gas. Right, so how can we predict the salt that is produced here? We will take the positive ion from the alkali, potassium ion there. So that is K plus. And then we'll take the negative ion from the ammonium salt. So this is SO4 2 minus sulfate ion. Hence our product should be, the salt is potassium sulfate. And the other two products will be water plus ammonia. So let us write down our equation now. Ammonium ion is over here. So it has a formula of NH4 plus. With that, the formula for ammonium sulfate should be NH4 bracket 2 SO4. This is in aqueous state. Okay, plus aqueous potassium hydroxide. Potassium is K plus, hydroxide ion has a formula OH minus. So this is KOH bracket AQ. And I get potassium sulfate. It is K plus and SO4 2 minus. So together that will be K2SO4 aqueous. All salts over here are aqueous states plus water, liquid, plus ammonia gas, which is NH3 bracket G. Okay, so first step to balancing equation, please always check that if there are common molecular ions that are present. So the common molecular ion that is present over here will be sulfate. If there is a common molecular ion, please just balance them as one set instead of splitting them up. Okay, then let us write down the elements that are present on both sides of the equation. So on the left, I have nitrogen. Okay, so starting from the left over here, nitrogen, I've got hydrogen, then I have sulfate ion, I have potassium, and then oxygen. Okay, so let's count. This is NH4 bracket 2 which means that I have two sets of ammonium ion here. Right, so I will have two nitrogen. Hydrogen over here is 4 times 2, so that's 8. Sulfate, there's 1. Okay, then in potassium hydroxide, K over here is 1, oxygen 1, and I've got one more hydrogen over here. So we've got to add it back to the count of hydrogen. So that's 8 plus 1. Okay, on the right hand side, starting with potassium sulfate. So there are 2 potassium, 1 sulfate ion. Then for water, I've got 2 hydrogen, 1 oxygen. And in ammonia, I have got 1 nitrogen plus another 3 more hydrogen here. So let's see, how can we balance this equation? As a rule of thumb, let's leave nitrogen and hydrogen to be the last to be balanced. Okay, so you will notice that nitrogen is not balanced. Similarly, potassium is not balanced. So if I want to balance up my nitrogen, I will have to multiply by a 2 on the right hand side of the equation. See, so that means I will put a coefficient 2 in front of ammonia. So let's update our numbers. Now this is 2 nitrogen, and then I will have, this will be 2 plus 6. Okay, then for potassium, over here just now, there was 1 potassium on the left, but there's 2 on the right. So I will need to make sure that there are equal number of potassium. So let's change this and let's put coefficient 2 in front of potassium hydroxide and update our numbers again. So K will be 2 and oxygen here is 2 and hydrogen will be 8 plus 2. Okay, so let's count. Nitrogen is balanced, right? I've got 2 and 2 nitrogen. Hydrogen, I've got 10, but on the right hand side I've got 8. So hydrogen is still not balanced yet. Sulfate, yes. Potassium, yes. And oxygen is not balanced yet. So what I need to do is I need to make sure that I've got 2 oxygen on the right hand side, right? Because there's 2 here and there's only 1 here. So I need to make sure that there are 2 here. And to do that, I'll put coefficient 2 in front of water. So with that, the number of hydrogen also changed. And previously, this 2 was from here. So now it will, instead of having 2 hydrogen here, it should be 4 because it's 2 times 2. Okay, so back to our numbers again. Oxygen is now balanced and hydrogen, it is also now balanced because on the left, I've got 8 plus 2 equals to 10. On the right, I've got 4 plus 6 equals to 10 as well. So this is how we balance our equation. All right. So I will put up the rest of the answers of the equation onto Google Classroom for you to just check your answer after you have tried out on your own for this page. And I will need you to complete this section as homework. Okay, so complete this section as homework by taking a photo and complete it in your book. Then take a photo of this portion and upload it in PDF format on Google Classroom. I will also upload another video for you to show you how you can make use of the Google Drive app to upload PDF directly onto the Google Classroom page. Okay, that's it.